Hey guys, I guess some of you have already started the happy hour, so I'll keep it brief. So I won't stand between you and the beer, which is pretty good, by the way. So my name is Marcin. I'm a production engineer at Facebook, and while I was driving here, like yesterday, I was taking an Uber to the airport, and my Uber driver, as they do, he asked me what do I do at Facebook, and I told him that essentially I enable software engineers to run their services in production. And he was like, so you're a DevOps? And I was like, yeah, kinda, but we don't call it that. Because at Facebook we call it production engineering, which is essentially, well, you guys heard about Adam Jacob. He wrote Chef. He's one of the people that coined the phrase DevOps. And he had a great talk last year at ChefConf, I believe. And he was talking about Devops Kungfu, which is essentially if you're doing DevOps, you will know it, and you will know that you will easily recognize other people that are doing it. But there is no one good way, and everyone has their own flavor of it, or everyone has their own way of doing it. And that's essentially what we are at production engineering. We don't call it that. It's just the way we are. And I very much subscribe to the idea of it's like Kung Fu. It's the way of doing things, not necessarily calling them that. So without further ado, Facebook uses Chef at large. We are one of the largest Chef deployments in the world. And a few years back, when we were migrating from CF Engine to something, we needed to clean the mess that CF Engine was. And we were looking for something to fit our needs. And the prerequisites were essentially this. We needed something to manage hundreds of thousands heterogeneous systems, and also for it to be flexible so we can delegate. We don't delegate configuration to service owners. We didn't want to centralize to have one team that writes all your Chef code and is running all your production. That's not the way we run. We have service owners that are responsible for their things from writing it to production, including on-call shifts and all that. So we needed something flexible to delegate parts of the configuration to someone and let him run with it. Those were two major prerequisites. And we tested a bunch of solutions at the time, like Puppet, what have you, and others. And we came up, like after some deliberation and through testing, we came up with the Chef model that worked for us the best. So we needed something to be composed of reusable building blocks, which will be the cookbooks themselves, that will interoperate very easily and will be able, and people will be able to reuse them as they wish. But also we'll have assign defaults that if you don't have to know the details and all the intricacies of the configuration of the service you're installing on your box. You need to just know high level, and if you need to go into the detail, you will. And essentially, configuration is data. So if you don't need something specific, for something very tailored to your needs, all you need is define configuration as data in the node object and run with that. You don't have to specifically write too much code. We wanted for it to be declarative. And Chef, by its very definition as being just a thin DSL on top of Ruby, is a full language. So our way includes skipping all the Chef parts and just doing declarative invocations, but we'll get to that. And we wanted for it to be idempotent, which means essentially we need resources to know when they're supposed to be running and apply just what needs to be applied, not like in CF Engine land, things got applied numerous times. So with that in mind, we essentially rely on convergence, which means you need to run your chef only once. If something went wrong, it's going to fail. It's going to fail hard, and it's going to tell you about it. And if your chef is failing for extended periods of time, your system will fall out of compliance, will either get reprovisioned or stuff will happen, alarms will get raised. So there is no partial consistency in this model, in this world. There is only you are either compliant and running chef properly, or you're raising an alarm. What happens to the alarm depends on how the service owner handles it and what he wants to do with the alert itself. But that's the way the chef layer works. Our cookbooks are meant to be scalable, reusable, and have sensible defaults. And out of those, the sensible defaults are most important. In previous world, in CF Engine land, we had multiple people defining their own sets, full sets of syscattles. And if something was applicable to their tier, they just adjusted that, right? But at the same time, they pulled in numerous values that were just there because someone else did it, and they copied the entire file and then ran with the entire thing, which we ended up with hundreds, literally hundreds of copies of syscattle configurations across the fleet, which was impossible to manage. Like, we came up with a, I don't know, new kernel or something else that needed to be adjusted, and it was impossible. So with the new world, with the chef managed approach of sensible defaults and changing only what you need, you just change things that you care about. Everything else is managed by someone who knows what is a sensible default. So easy delta delegation is exactly that. It's letting your users or whoever be it other departments, other teams, be it software engineers or whoever, just adjust just what they want and skip the rest. And this is we accomplished that through the Cookbook APIs. Cookbook APIs, you guys know Chef, or some of you do, and there's the node object, right? It's a huge hash of basically data. That's what it is, and you can change the data at any time, at compile time or at runtime, right? And all the adjustments that happen at compile time will get delivered to the cookbook that consumes that part of the node object, and will take effect in during the runtime. And we build those. We build abstractions over fundamental building blocks. To be clear, we're not, for the most part, not deploying services as microservices, a hip word, through Chef, or we're not yet running inside containers. Those are mostly things that everyone runs, or particular teams with enough operational aptitude care about running like on bare metal, right? Which is not necessarily everything. Easy to use APIs inside the node object. And as I mentioned, configuration is data. If you need something more specific, no one stops you from doing crazy things to the node object, munging that data and spitting something else. But by the end of the day, you are just providing data to the consumer, to the cookbook that will be consuming your data. And that's how the API works. And by the nature of those APIs, we make the simple things easy, but at the same time, we leave them open-ended. So if you need to completely change the way the cookbook is going to work, like erase everything that is there that other people put into that particular Cookbooks API, you can do that, and you can override everything you can think of, at least in the same cases. And we did open source most of our cookbooks like a month ago, I think. So there was a blog post. You guys can go to Facebook's engineering blog and read. There's plenty written about our model, and there's like 15-ish to maybe 20 cookbooks that are ready to use with great documentation and great explanation how to actually use that. And this all fits into how we have written. So we have written them in the way that cookbooks need to comprehensively own their space, which unfortunately, like, we needed to rewrite plenty of community cookbooks. If you ever used community cookbooks as ops former company, the actor formerly known as OpsCode, nowadays it's Chef Inc. They used to call them community cookbooks, and those were maintained by OpsCode, sort of, but written by community. They were, for the most part, unusable, unfortunately, at least for us, because they were either too specific that they didn't provide any kind of sane defaults, or they provided no ways of actually tweaking the behavior, right? So, and also, neither of them comprehensively own their space. What do I mean by that? If you have a cron cookbook and you manually add a cron job, like you go to the box and you add a cron job, should that cron job survive the chef run? What do you think? No, it shouldn't. It should get wiped, because the cron cookbook should comprehensively own its space. Same with FSTop, same with other things. That whatever is there, defined and codified in the cookbooks, should get applied, and everything else that is basically someone tweaking their system in a non-compliant way should get wiped. And this is not how most of community cookbooks operate. They just try to be sensible about things. They just add to whatever is there, which maybe works for my home server if I happened to use the same model, but I mean, not the same model, but to use that specific community cookbook and tinker with the box manually because I was lazy. But it won't fly in a properly managed environment. So that's what we encourage. We encourage cookbooks to own their space wholesale. It's extremely difficult in some cases, especially with things like mounting disks, right? It's a very sensitive thing, but we did that, and I think that one in particular is open source, and it's pretty awesome. So wasn't this supposed to be about testing? So it was, but we're gonna get to that. I needed to give you guys an overview of how we run in production. So now testing. So staging, pre-production, sandbox. No, we don't do any of that, which is a little bit unorthodox. We have tens of changes every day to common cookbook code base, and it essentially takes 2 engineers to commit chef code, one guy to write it and the other guy to review it or stamp it, right? And it takes literally 5 minutes, because the cron job runs every 5 minutes, for that code to start hitting production at large. And after 30 minutes, it's gonna get applied everywhere, and I mean everywhere, because we run chef every 15 minutes with 15 minutes play. So we do the standard things like everyone. Chef spec, Rubocop, food critic. We actually wrote plenty of food critic rules and significantly contributed to the open source project. Not everything is open sourceable, but we have a ton of both internal and wrote plenty of external rules. But yeah, that's how we run. We don't always test. We don't test in production. Well, we do test in production if we happen to test. We use a tool called Taste Tester, which manages a local Chef0 instance for you, tracks all the changes you are doing, and you choose a box, a host in production, and you point it at your local Chef0 instance. And at this moment, you are, whatever you just wrote, whatever cookbooks you just wrote, you are running that server against your changes, which is insane when you think about it, and honestly pretty scary. But it's necessary. Is it dangerous? Well, it is dangerous only if you don't know what you're doing. But the very essence of the model is that you hire people that you trust, or you trust the people that you hire. Well, it boils down to the same thing. The people will know what they are doing, or if they don't, they will come to you as the maintainer of the chef infrastructure or the local chef guru, and they will ask, and you will help them. And we found this to be the necessary way of actually knowing what the changes will do. So how does this really work day to day, like on daily basis? I write my tests. Maybe I do, maybe I don't, like in ChefSpec or RSpec. But I cannot do full coverage ever. And I'm taste testing it. And I will likely choose a host in the production that will apply my changes and will be meaningful for that particular change to get applied. And then I'm good, right? I'm submitting the diff for review. And then there comes another person that, like my colleague, which I randomly chose to be the reviewer of that particular change. And he comments with that and approves the diff, right? Well, it looks vaguely like the right language. So I'm just going to go ahead and let it slide. It's Friday evening. Who cares? Right? So I'm going to push that to production, right? No, I won't. On top of Taste Tester, we build another tool, which is vaguely resemblant of whatever kitchen CI does, which is like Taste Tester, but automated. We take your diff, we apply it across a variety of tiers of host prefixes or however you're going to call them, and or roles. And we're going to see what happens. And if the chef succeeds, there is a fair chance that, or at least some chance, that the change you're doing is going to be fine, unless it goes poorly. But that's the point. Like, we're not going to police you. We're not going to prevent you from doing your work in a reasonable pace. We're not gonna force you to go through a series of code reviews and have a dedicated team of people to just review chef diffs or anything like that. Well, we will for very core things, but not for whatever you are owning as the maintainer. And that's essentially where our workflow nowadays. Does it apply to everyone? Well, not necessarily. Not necessarily because, first of all, you need to be able to pull hosts out of production and test on them. If you have enough of them, that's likely going to be fine. But even if you break something, but if you're a grown-up, you won't. And to be honest with you, when I came to Facebook, that model was already in place to some extent, that I'm testing my code in production and I'm running against the live production system. And it was terrifying for the first month or two, because me, knowing Chef a little, I'm now taking live systems and trying out whatever I just wrote, which might be well, it might have bugs, it might be garbage, but at the same time, it takes, it speeds you up, but it puts tremendous responsibility on you. You need to be a grown-up to do that, but we all are, or at least pretend to be. So yeah, it sometimes ends like this. You can totally skip all the, you can skip taste tester, you can fake it, you can make autotaste not do the right thing, but it boils down to you trusting your engineers with, well, giving them all the tools, and well, trusting that they will do the right thing and not burn the house down. Well, it works for some environments. And what about functional or integration, or however you call it, testing? So we tried doing that, things like server spec or others, but we decided that in the end, it's extremely hard to cover your cookbooks with to a reasonable extent, and your code is already your tests. If you test in production, and if you take a host and try it out and see for yourself, you're writing your tests as you write your code. So it might work for you. It might work for your environment, especially if you have some kind of legal or other compliance issues, but it doesn't have to. And if something goes wrong, your code will automatically correct the state and fail hard if not possible. That's the very important part of that model. That if something is not there, correct it. But if you're unable to correct, and just fail and raise for someone to take a look at it. Because if you don't have good monitoring around it, this is all going to end badly. But if you do, then you might benefit from it tremendously. So it's a bumpy ride. This is actual Star Trek, but just stabilized. So this is what they were doing on the set. But it's a bumpy ride oftentimes, because you can totally fake all the tests and do something stupid. And we're all humans, we do that. We land codes on Friday evening, right? But you do it only once, because if you do it twice, we're gonna come back to you and have a frank conversation, and we're just gonna work with you to get better, iteratively, but better. So lessons learned from a few years now of Chef at Facebook. Testing against real systems is tremendously useful, and for our environment is necessary. And I can imagine a world where you can fake it by spawning entire clusters of machines and checking if they comply with whatever tests you have. That's another way to doing that, but that's slow, and we're not about being slow here. We need to deploy fast, we need to move fast, and sometimes it happens to be breaking things, but that's the risk we are willing to take. And putting trust in the people you have around, it really pays off. So, thank you. Thanks to the awesome people I work with, Phil, Devops, the chef guru, and everyone else, Aaron, Bethany, Casey, Brian, David, and Pat, and Hussein. And that's all I got. We're hiring, by the way. So if you have any questions, shoot away.
Okay, so do we have any questions? I'm sure we do.
Okay, maybe naive question. So it just sounded like we don't do tests because we are so cool that nothing will ever break.
Oh no, it breaks all the time.
But why doesn't it break in a such way that it actually becomes painful? So just because you have many servers and if it breaks on some of them, it's not a problem?
No.
Or it's just that because of the whole thing, maybe some comments will show up in a different order, it's not a problem.
Somewhat.
No, I mean, just the nature of Facebook, nothing can break in such way that it will, I know, cost billions of dollars, something
Oh,
like
it
that.
totally can. If you run rm minus rf on a database, it's gonna be like, it's gonna end badly, and you can totally do that. But we trust you not to, right? That's the entire point of that model. We don't put too many roadblocks on your path to landing stuff in production and applying your changes. But at the same time, we trust you not to break too many things. And you will break things. Occasionally, we had problems with that. We didn't bring Facebook down, but we occasionally had problems that, okay, how do we get out of this mess? But after enough times working with service owners and developing a culture of responsible changes, people are just able to do everything at a great pace. They don't need to wait a week for a review from a blessed, dedicated chef team to get something done. They just apply their changes, and they are trusted to be grown-ups about it. So it's a trade-off, definitely. And it did cause some pains. But, yeah.
Do you believe that this same kind of operations would be possible for example, let's say, financial institution or a production company which does some manufacturing, system automation, and so on whatsoever?
Well, depends on which parts. The parts that if something's not compliant, then you break like you fail chef and raise on that. That's totally possible. If you have too many, if you have some regulatory issues, then, well, not necessarily. As I said, we don't have too many of those. That is, we can apply our code in production, and it takes two people to review it. So, possibly.
Do you do some kind of canary testing, like putting these changes to the production only for the limited number of servers?
Yeah, that's taste tester. You manually take hosts, you choose hosts that will be relevant to your test. You run chef against your changes, and you see what happens. If that happens to be one host, because that's what you chose, that's gonna be one host, and that's it.
Okay, so what part, by percentage, of the final users are affected by the new changes at the beginning?
It depends. It usually depends. If it's a cookbook, one of the core ones, or one of the ones that we open sourced, mostly all of them. If there is something breaking in one of those, right? So you take a few hosts, numerous hosts, you test on them, and you get a reasonable degree of certainty that it's going to be fine.
There was someone over here. I will move.
Okay, I have partially heard the answer to my question, but Facebook is a large company, and there are many commits. Like you said, every 30 seconds there is some change going to the production.
Yep.
So how do you manage things that break not directly that commit on, but affect things more subtly, and that these things came later in more widespread deployment?
Well, you mean changes that, for example, didn't break chef, didn't break the chef run, but still did a subtle change to the system. That's what you mean?
Yes, unwanted subtle change.
So, well, that's for someone to notice. But isn't it in all the systems, I guess? Someone will eventually figure it out that something went wrong a week ago, right? And it's pretty subtle, as you said. Subtle changes are, well, by their nature, subtle to detect. So I don't believe any kind of other testing unless it's very slow to, like, if you slow down your pace of moving infrastructure to, yes, we're gonna now run this for a week and see what happens, right? If you slow down to that pace, possibly you can catch those, depending on how subtle the change is, right? But if you want to leave the openness of moving fast in a reasonable pace, then, well, something's gonna detect it at some point. And it's gonna get corrected. It's not that someone will get blamed for it. Not at all.
There was someone up here? No?
I think that for further discussion, it's worth of clarifying what is the state of this host taken for tests. And I think that my colleague was trying to find out if production data are affected by this wrong changes, and if this host is still exposed for clients.
So
and what about the idea to have them all switch to templates of data and run automated tests on them before, and of course they can reveal some bugs during this automated tests, and after that return to production.
So our Chef deployment won't do things like web disks, for example, right? It's very rarely destructive in that way, unless you specifically do something stupid. But it would need to be very stupid, like instead of removing user local something, you put a space in the middle, right? And we've seen that happen to some open source projects years back, that they were just wiping things accidentally like that. But I don't think it ever happened. In theory, yes, you can wipe all the disks, but would you?
I shall comment, but maybe it is a way for some extra security for financial institution that would try to follow your model.
Well, I don't necessarily know the limitations that would work or not, that would be imposed on a financial institution. So we can take that offline. We can chat about it.
Okay, I have two questions. One question is, you just said that you just nominate one of the node and just test your code. So
yep.
my question is, how did you do you resolve the problem with two people nominate different hosts and test exactly the changing about the same part of the code? This is the first question. And the second question is that true that one of the idea behind that really strange, what you said, testing on the production is that when you deploy your changes immediately on the production, you immediately can see performance impact and how you measure the performance impact of your changes.
Yeah, so the first part of your question, taste tester will tell you if someone is already testing on that particular host. It will detect it. And more than that, the chance of you actually hitting randomly choosing a host that will be chosen by someone else at that very moment is very slim. It happens, and it did happen, but taste tester have safeguards for that, so it can be in test by one person at the time. It won't let you put the host in a test mode if someone else is already testing on it. And the second part of your question was to, sorry, what was that?
To measure the performance test, and if it is one of the idea behind such thing.
Yeah, so we don't deploy very high-level applications through Chef. That's more of a different systems that are more, I would say, granular and more deliberate in their efforts, more focused on particular applications, I would say. So if you're changing a sysctl, for example, which is a good example of something that would affect performance, you will, for example, put, instead of one host, put numerous hosts into testing mode and test on those. And if your application happens to have good enough instrumentation for measuring performance, and they do, because we all do that and are grown-ups, then you can totally test that, detect that in that model. Just putting more into the testing, but if you know that something can affect performance, like tweaking, I don't know, sysctls or NFS mount options and stuff like that, then you will be very deliberate about your change. You will sanely choose the scope of your testing.
So, okay.
Okay, so when you fail, what's next? What's happened with
When
this?
Chef fails?
Yeah, well, when you choose some host on production and you fail, okay, I mean the procedure fails, and what's next?
So you mean in the manual testing or just regular Chef runs?
Both.
So, okay, so there are report handlers in Chef, which will report back to something, whatever you have. We happen to have a pretty decent logging system. And if it's in test mode, it's not automated. You're going to go to the box. You're going to run chefctl or chef CTL, which is our wrapper around chef client, essentially. I think it's also on GitHub. You're going to run that, and you're going to see your changes being applied or not. And it's going to fail in your face. So that's in testing. Because you're experimenting with a live system, you're watching it fail. So that's what happens. It's going to get reported somewhere, but it doesn't really matter in that case because, well, you're testing. But if it fails at large, if you happened to commit a bad change and it breaks Chef, it's also report handlers commit to report to some centralized place, and if there is enough spike in failures, then alarms get raised. And also, if a particular host, one host, is not compliant, it's for some reason you went to a random production host and you broke it in a way that Chef cannot recover, then it's going to start failing. And if it fails for long enough, someone is going to, it's an alarm, and different alarm is going to get raised. Someone is going to get notified, either by task or an SMS or something else. And it will be for a human to decide. But some teams chose to automate that process. If something happens to break on their host, and they don't really care because their hosts are either compliant or not, then they just get reprovisioned. Because reprovisioning is sensible enough to keep production data, take the traffic off, and stuff like that. So it's a numbers game to some extent, that if you have enough hosts, you just care about the majority of them. But it goes all the way, starting from Chef, but going all the way to the application layer.
All right. So if you screw, I mean, you have to fix it, or you, I mean, from human perspective,
Yeah.
right? I'm the engineer, and
Yeah.
I failed.
You committed a bot change.
Yeah.
That started failing Chef throughout the fleet.
Right.
Then you will likely get paged in minutes, literally minutes. And, well, you look up what the change was, you figure out what went wrong, and you commit another Chef change to fix it up. You just react, right? We're not rolling back or anything like that. We're just moving forward. There is no automated rollback, and this was a good version, this one's bad, so we're going to go back. Because by very nature of Chef changes, sometimes it would be a little scary to roll back Chef changes, because those are system changes. Oftentimes, it's not reversible to cover the logic that went into the change. So it needs human interaction if something went wrong. But it's up to the person that made the change and created the bad situation.
Okay, who's up next?
So I have somehow like similar questions. So it's like from the developer's perspective, like how do developers like this approach of having just one environment? Because like from my experience, developers always want like more environments to test their like changes. And isn't it like stressful for developers that they might like do something wrong on the production? And does it mean that they avoid deployments after 1 p.m. or something like that?
Yeah. So Chef is not necessarily used for customer-facing things, right? It's not in our world, it's not a application deployment mechanism, unless it is, for example, for Hadoop or other things. But oftentimes the service owners or the application owners won't really do that through Chef. Not everything is an RPM, not everything needs to be deployed through system-level mechanisms. So oftentimes it's just further up the stack, if that answers your question.
Machine, not application.
For systems that are widely distributed and also touching, somehow being considered generic system or not really an application in a sense that it would go into a container or something, right?
Anyone?
And the last question, what about containers? Do you plan to using Chef or it's only for the different?
Yeah, so we are moving to that model right now. We used to have, that's entirely different space and a different subject, but we used to have more of a setup once run for a period of time containers. Now we're moving to fully Chefified every 15 minutes or so, like the vanilla Chef we have. It's likely it will be likely a different code base or slightly different because of containers needs, but we're getting there. But yes.
I have the question. My question is about the large scalability and contextualization files. What about it, and where do you keep the contextualization?
What do you mean by that?
The variables of the models of variables of the cookbooks. So, for example,
like
you have the files, yeah, and each of the file can have the variables, and for example, some end nodes, the variables can be different. Do you have some configuration like that?
Oh, you mean like, for example, something that goes into a template? It gets calculated by...
Yes, lookup vars and something like that.
For the most part, I would say calculated from whatever your Chef code will be doing, right? There is no much need for external instrumentation.
Node classifiers, yeah? ENC.
Oh, so for example, what should be applied to particular hosts?
Yes.
So this is based on the tier prefixes or host names. You have, for example, like tier of web-facing machines or MySQLs, right? Those won't be generic server 5073, right? Yeah. It's going to be named something, and it will be easy to determine what that host is supposed to be, right?
Yes.
So.
Okay, that's my question. Thank you.
Do we have some more questions?
Actually, two questions. One is related to, do you have your team working on cookbooks just as a bunch of individuals which each one developing some functionality, or do you have some kind of structure, rule book, architecture of how things should be done, how should they be maintained, and so on. That would be one question. And the other one, somehow related, is there any formal review process and change control to the changes? To some degree, you already have responded, because you say that you just go on and see if something's broken or not. But maybe there is also some kind of registering changes and peer reviews which are more formal.
Yeah, so if you're developing something new, it needs to follow the model for providing a sane API if it has the possibility of doing that. For example, I don't know, install syslog on my server, right? But it can be customized, so you need to expose that API in your cookbook. And that's essentially the requirement. It needs to play well with other cookbooks, and you can see examples of those on GitHub. There's plenty. That's all there is. If it's going to get widely distributed to everyone and people will start using it across the different teams, then it needs to follow that model. That's the hard requirement. And people will generally follow that. And if they don't, then there happens to come at some point, there comes someone else along and tries to use their cookbook in a manner they're using all of the others, and it's not there, so they just like, hey, could you fix it up to follow the model? So it's casual, but there is no like hard process that you need to provide API if it doesn't make sense. But if it does, then you're gonna do it. That's to answer the first part. And the other part, yes, well, there is, as I said, there is the review process for every change. It takes 2 engineers to push code, and once you put it up, someone will have to look at it. Will he just stamp it and vaguely decide, it's the right language, let's see what happens? Or will he just scrutinize every line? That depends on your code and your dev that you're putting up. But yes, every single change that goes in production is well documented because it goes through the review process. You couldn't possibly land something to affect everyone without that review. So.
Actually, I was interested also in this second part of the question. Is this process somehow automated? Is it so, formally, let's say, some Jenkins pipeline, or which requires some steps and approvals, or is it just casual conversation? Talk and
Well, someone needs to go and approve your diff in Fabricator. Fabricator is the tool we use for code reviews, which is pretty awesome, by the way. And someone needs to go there and click the button that, yes, this looks vaguely okay. So in that manner, it is manual. And you basically choose which people will gonna get included as reviewers. And it's usually you choose people that would make sense, that have context on that change. They either change that code before, or they somehow know that system you're touching, or they have some stake in it, right?